combination of functions, which are sometimes called composite functions. So, this is not a multiplication symbol, this little dot. It's an open dot, this little circle, okay? And what it means is that we're composing the two functions together. So, f composed with g is the same thing as f of g of x. What does that mean? It means we take g of x, plug it in for x in f, and then simplify. We're going to work some examples. So, the first one, we're given that f of x is 5x plus 6, and g of x is 2x squared minus x minus 1. And we want to find the composition of f and g. Remember, that means the same thing as f of g of x. I'm going to make g of x here teal and f pink, at least to start with. So, we have f of, and I write it like this so it's a little bit easier to see, g of x. So, g of x was 2x squared minus x minus 1. And so what we do is we take f of x, and everywhere we see an x, we plug in g of x. So f of g of x, without being simplified, is 5 times 2x squared minus x plus 1, and then plus 6. Simplify by distributing. And combine the like terms, just that 5 and 6. Let's see. This is supposed to be a minus 1, which means that's supposed to be a minus 5. There we go. So f of g of x is 10x squared minus 5x plus 1. And here they are graphed. I used the right colors. So this one's f of x. The pink one is just a line. The teal one is a parabola. And then when you combine them, you still have a parabola, but it's skinnier. Okay, how do we find the domain of these? If we're looking for the domain, then you have to consider two things. You have to consider the f of g of x for the domain, but you also have to consider g of x. So let's look at an example. First, we're going to find f of g of x here. So again, I'm going to use pink and teal. So f, of g of x is f of, and g of x is 1 over x. So wherever we see an x in f, we're going to put 1 over x. So we end up with this messy little thing, which we have to simplify. So let's get started on that. Do I have more space? Nope. Okay, so on the bottom, we need to get like terms. So if we multiply the 2 by x over x, then we got 2x over x. And so that can give us 1 plus 2x over x. Go up here. 4 is the same thing as 4 over 1. And remember, when we divide, we flip and multiply. So it's divided by 1 plus 2x over x, which means we're going to multiply by x over 1 plus 2x. And you just multiply straight across. So we have 4x over 1 plus 2x. For example 2, we're going to take that function that we've just found of f of g of x, and we want to find the domain. Okay, so remember what I said. We need to look at f of g of x, and we need to look at g of x. So first, find the domain of f of g of x. Start by seeing what we're not equal to on the bottom. So set the bottom equal to 0 and solve for x. So 4x over 1 plus 2x is not defined at x equals negative 1/2. For g of x, the domain is just x can't be 0. So the domain of f of g of x, because we've combined these, we can't just use this part. We have to use g of x too. And if you graph them, you'll see that there's actually a hole. So our domain is negative infinity to negative 1/2, not included, unioned with negative 1/2 to 0, not included, unioned with 0 to infinity. And I've got these graphed here. So the blue one is f of x. The yellow one is g of x. And the green one is f of g of x. And you can see that when this is graphed, that there is an asymptote at negative 1/2. We're focusing on the green one right now, okay? So it's undefined at negative 1/2, and there's also a hole at 0. It's also undefined at 0. How do you decompose functions? It's not as hard as it sounds. So, if you're going to decompose functions, then we're going to take this function and I'm going to change it into f of x and d of x. Just picking a letter there. So, if we want it to be as if it were f of d of x, then d of x is going inside of f. So the inside is d, x squared plus 5. What's left, where did it go into? Just a square root of x. And that's all you have to do. So again, if we want this one to be f of d of x, then what's going inside what? Well, the 3x minus 4 is inside of a fraction. So 3x minus 4 is inside the fraction of 2 over x. Can you see that? The 3x minus 4 just went in place of this x here and became f of d of x. And that concludes the section on combinations of functions.